We'll start with some cross-site request forgery. It's an interesting one, and I apologize if we kind of just jump really hard into this. It might be a jolt, but hopefully we can get through the rest quickly.
Basically, I have a demo for you, where you will be able to see how these attacks can be performed.
So I was browsing online one day, and then I came across this blog. It's pretty interesting, pretty boring, pretty simple. I guess it's some lady. She's got 4 dogs, 7 cats, 2 husbands, daughters, sons. Anyways, so she likes to create blogs. She likes to create websites, kind of just learning a little bit about it. She wants to get into this professionally. She's got some contact information. Give her a call if you want a website.
Or avoid.
Or avoid. So, I mean, let's take her around. She's got a first post. There's some comments. The guy doesn't like her blog. You could leave your own if you wanted to. Second post, guess something not nice has happened. Don't really know what right now, so let's just browse around a bit. So, naturally we all like to click things. They're very clicky. So let's click this link. So someone out there is really mean, doesn't like this blog. The site sucks, it's got security vulnerabilities, at least this person thinks. Avoid it, don't go there. You'll get viruses, Trojan worms, everything evil. So, to save some time, I'm just going to go back here. Now if you remember, there were no comments on this second post. There is a comment now. Someone who was very mean, they said, her site sucks, she sucks, not very nice. So, if you've actually been paying attention to me, I didn't do anything. At least, I don't think I did anything. So how could this have possibly happened? So this exploit itself was called a cross-site request forgery. You'll either see it CSRF or XSRF. And how did it happen? Well, when I click this link, copy link location. Actually, I need to go here. So it's a regular website, and I copied and pasted the link so you could actually see that there's nothing really too nefarious going on. There wasn't a on-click action, so on and so forth. But if I refresh this page now, if all went according to plan, which it didn't, if I cache refresh it, I'm on the wrong post, that's why. You'll actually see, and I did it 3 times, there's now 3 comments. These people are really mean. So what's actually happened here? And again, I didn't type any comments. I just went to this one website and new comments showed up. So how could this possibly have happened? Let's take a look at the network. Now, if you haven't seen development tools, Chrome has it, Firefox has it as a plugin called Firebug. It's a way of interacting with your website on a slightly more protocol level. So you can see the HTML of the page, you can see the network calls, your cookies. Take a look if you've never used it. If you have, that's awesome. So let's reload this page, maybe. And there's one interesting network call going on here. So the URL of this website is yourblogssucks.blog.example.com. But one of these posts, can everyone see my cursor? Yes. So one of these posts right here is actually to stuffandthings.blog.example.com. That doesn't make a lot of sense. Let's take a quick look at it. And I'm sorry that that font is so small. I'll try to explain. So we had a request. It was an HTTP post. Now, some of you weren't familiar with how HTTP works. I'll try to distill it very quickly. I won't do a good job, but I'll try. HTTP is a request response protocol. You make a request to a server, and the server sends you a response back. There's sort of mechanisms built in. It was really engineered and built around the time that web security wasn't a thing. It was built around the time when I built my first page, here's some information to the next university. This is pretty awesome. So, going from one domain to another is generally not allowable or acceptable. But what's actually happened here is it happened. And what actually happened, so I went to stuffandthings.blog.example.com, and the actual content itself was a comment. Comment, body, haha, another person thinks your site is not good. Commenter, some mean person, email, some other email address. How did that happen? Oops. The actual content of this blog embedded some JavaScript. In this case, it's an XML HTTP request, often known as AJAX. And it's effectively just a way of having your JavaScript call another website, or your own website ideally, to make a call and post some data. So in this case, it was an HTTP post, and it said, post this comment on the site. So this is a violation of, well, it's a cross-site request forgery. For example, you might have heard way back when Twitter originally launched, you might go to a website and you'd have things posted on your feed. That's kind of XSRF. You might also think maybe you go to a bank, all of a sudden your deposit is now, or your balance is now zero. Probably also an XSRF attack, nothing more nefarious. It doesn't happen that often anymore because we've smartened up, but it is still an issue to watch out for. Did that make sense so far?
Right.
Okay. This button. Technical difficulties. Okay. So I'm going to hand it over to Alexei to go through a bit of an analysis about how you can solve this problem or mitigate this problem.
So what happened here is that an attacker actually took over the browser from you. You think you're in full control of that browser, but somebody's actually driving the browser and doing things on your behalf that you're not aware of. So servers need to protect themselves. They need to find a way to ensure that the person, that you, this physical person, is the one that is actually executing those actions on purpose, and not some other person that basically injecting some JavaScript or whatever in there. So how do you protect yourself from that? Well, basically you have to be able to identify each one of those calls that are made to your server. What do you do? Well, when your page is loaded, you basically send back with your page a piece of information, basically a piece of information that is going to be sent back to you with every request, and you'll be able to check it to make sure that you actually were the one that served that page originally, and that request is actually legitimate. It's not coming from somebody else. In this case, we're not doing that check, and that's why when you went to your page, the request was made to your site, and your site just went and processed it, thinking that everything was cool. So basically, that's conceptually, that's what you need to do. This one here, you have to validate. It has to do, it's all related to validating the origin of the action. Basically, using that mechanism, you can ensure that that action was originated from your site and not from another site. Is that more or less clear? So basically, you're gonna send something that is encrypted, that you're the only one that knows how to decrypt, something along those lines.
I have a question.
Sure.
How does the server, when it receives back that information, how does it check to see if that information is correct? Like the token, basically, you're talking about the token.
Yes.
How does it know that token is valid and not like that the attacker generated the token by himself? How does it do it?
Because that algorithm that the scheme that you use to generate the token is only known by you. Let's say that you base it on the user ID, or perhaps the current date or something like that, and you're the only one that knows that scheme.
Okay.
So that the attacker cannot basically fake that token.
Random in that case is best.
Exactly.
So generally you'd use a header or a cookie. Headers mostly simpler with HTTP XML requests or AJAX. Cookies usually being better for browser posts. And effectively within, you'd write to a cookie, for example, and you say, this user is session, I don't know, 25,304,000,004, whatever. Some random number that's very difficult to guess or predict what the next one will be. That's kind of your session, and then you'll use that session to seed some sort of a value, whether it's encryption or hashing, whatever way it is, but so that when this token, which is derived from or somehow associated with that session, you can verify that, yes, we issued this for this session, and therefore whoever posted this actually knew what that token was and knew what that session was.
Oh, okay, so it's based off, so the token is sent, when you have a session on your computer, that means you have the cookie on your computer locally, and then it generates a token based on some value in the cookie.
Some derivative function, yes.
Okay, but the browser, the client, doesn't know about that function.
Exactly.
Correct.
Yeah.
Yeah.
So that means it would be unique to every different user. The token would be unique.
Usually per request, sometimes user. It all depends on what your security threat is, or your threat model and security risk,
Okay, you're
risk
right, because
level
if it would
is.
be per session, and that's not as secure.
It depends. Security is always a balance between simplicity and security, security being less risk. Sometimes the risk is very negligible, and therefore you may take shortcuts, or, I mean, simpler solutions, shortcuts is a bad word, simpler solutions that may not be as important. When it comes to XSRF, you probably want to be more on the strict side. But again, if a session on average lasts 20 minutes, the complexity of generating that session might not need to be worth 17 hours of compute time to figure it out. So it all depends on what your use case is on each instance.
Okay.
Okay. So something else that you can do to mitigate this type of attack is actually ensure that you follow the best practices for the HTTP protocol. So in HTTP, there are a certain number of request types. We have the GET request. GET requests are only meant to retrieve data. You're never supposed to change data with a GET request. Basically, when you go to a browser and you go to a website, that's a GET request. You're basically saying, give me this page. You're never supposed to change something like that. So that definitely you should always do that. Otherwise, somebody could actually break into your system by basically just putting together a URL with that data that we saw in the demo and just hit it, and they will actually be able to add a comment to the blog just like that. That doesn't really keep you safe. You can still do it using a post, but it takes a little bit more work. You actually need some JavaScript in the page, you need to send an AJAX request and that kind of stuff. It just makes it a little bit harder for an attacker. And then we have here a couple of basically examples of how you can kind of solve or mitigate this issue. In here, this is an example of what you will do if you're using Django. It's a framework to create web apps in Python. If you include this in your pages, that will basically make your page safe or less vulnerable to this type of attack. And this one here is kind of what you will do if you're creating a JSP-based Java application. This is obviously not the whole story. There is something that needs to generate these tokens and so on, but that's more or less what you will put in the page.
Yeah. So lots more work if you do it yourself. Probably prefer a third-party library. In this example, I had to explicitly configure Django to turn off XSRF prevention. So sometimes you actually have to go out of your way to make it vulnerable.
Like most modern frameworks protect you from this kind of attack. Yeah.
So